Okay, so here's another trig equation. Here we have the sine 2 theta. This one you would think that we need to do the coterminal angle stuff. That's really only when it's the sine 2 theta is equal to some value between -1 and 1. In this case, it has some other things, other trig functions in them, so we're just going to do a substitution here with this sine 2 theta. Hopefully you all know that the sine of 2 theta is equal to 2 sine theta cosine theta. So I'm going to replace that with 2 sine theta cosine theta times sine theta equals cosine theta. So here it would be a bad idea to divide both sides by cosine because you lose a solution. So we just want to multiply the two signs. So we get sine squared theta cosine theta equals the cosine of theta. I subtract cosine from both sides. Cosine theta minus cosine theta equals 0. Greatest common factor of cosine of theta give me 2 sine squared theta minus 1 equals 0. So the cosine of theta equals 0, and 2 sine squared theta minus 1 equals 0. I add 1 to both sides. I divide by 2, I get a half, and I take the square root of both sides, get plus or minus the square root of a half, where the square root of 1/2 is the same as square root of 1 is 1 over radical 2. If I rationalize it, one of the only times I think rationalizing is helpful, I get radical 2 over radical 4, which is the square root of 2 over 2, which is what we were looking for, is one of our known values. So plus or minus the square root of 2 over 2. So cosine equals 0 at pi over 2 and 3 pi over 2, and since it's plus or minus with pi over 4, we're going to have all the pi over 4 angles going all the way around the unit circle. So there's our answer. So this one we have sine 2 theta plus sine 4 theta. A good idea would be to replace sine 2 theta with 2 sine cosine. Unfortunately, there's really not an easy rule for sine 4 theta. So the way I manage this one is I let w equal 2 theta. In that case, I now have the sine of w plus this. If 2 theta is equal to w, that means 2w is equal to the sine of 4 theta. If w is equal to 2 theta is equal to 0. So again, we have the sine of 2w in this case. W equals 2 sine w cosine w. So we get this sine of w plus this is equal to 2 sine w cosine w equals 0. Take out a greatest common factor of the sine of w. I get 1 plus 2 cosine w equals 0. I get this sine of w equals 0, and I get 1 plus 2 cosine w equals 0. I subtract 1, and I divide by 2. So sine equals 0 at 0 and pi, and cosine equals -1/2 at pi thirds, but it's going to be in the negative quadrant, which is 2 pi thirds and 4 pi thirds. So right now we have 2 theta, or w, is equal to 0, pi, 2 pi thirds, and 4 pi thirds. Since we have 2 theta, we therefore want to add 2 pi to these two angles. I'm going to add 2 pi here. I'm also going to add 2 pi here, but I'm going to write it in terms of in terms of thirds. So therefore that would be 6 thirds is the same thing as 2 pi. So by adding 2 pi to these, I get 0 plus 2 pi is 2 pi, pi plus 2 pi is 3 pi, 2 thirds plus 6 thirds is 8 thirds pi, 4 plus 6 is 10 thirds pi. So now I have 2 theta is equal to these 8 angles, 0, pi, 2 thirds pi, 4 thirds pi, 2 pi, 3 pi, 8 thirds pi, 10/3 pi. Now again, note that right now we're solving for, right now we have 2 theta as our answer. We want our answer to be theta. So therefore, currently this angle is not extraneous, nor are any of these that are bigger than 2 pi, because we first have to get theta all by itself. So therefore we need to get rid of that 1/2. So I'm going to multiply both sides by 1/2. So I'll multiply this side by 1/2 as well. And the theta will go away, so I have theta. 1/2 times 0 is 0. 1/2 times pi is pi halves. You get the gist. 1/2 times 2/3 is pi thirds. 2/3 pi. Pi. 3 times 1/2 is 3 halves pi. 8/3 times 1/2 is 4/3 pi. 10/3 times 1/2 is 5/3 pi. And if we write our region, or our acceptable domain, between 0 and 2 pi inclusive, in terms of thirds, it'd be 0 and 6/3 pi, which is less than 5/3 is less than 6/3. So here are our 8 solutions here. Okay, in this one, again, we have the linear term secant theta. So we want to change this tangent squared into a secant expression. Well, hopefully you know that the tangent squared theta plus 1 is equal to secant squared theta. So therefore, I'm going to let tangent squared theta equal secant squared theta minus 1. So I'm going to replace secant squared theta minus 1 with tangent squared. So we get secant squared theta minus 1 equals 3 halves secant theta. I'm now going to multiply both sides by 2. I can multiply or divide by a number or a constant. You never just want to divide by x, or in this case a trig function. So I'm going to multiply everything by 2 because I'm not really dealing with that 2 in the denominator there. So I get 2 secant squared theta minus 2 equals 3 secant theta. I bring the 3 over, so I get 2 secant squared theta minus 3 secant theta minus 2 equals 0. To factor this, let's just let w equal secant theta. So this is another side note. So we have 2w squared minus 3w minus 2 equals 0. So 2 is prime, so it's 2w and w. I want a negative 3 in the middle, so that's minus 2 and plus 1. So therefore I can rewrite this as 2 secant theta plus 1. Secant, I almost put w again. Secant theta minus 2. So therefore I get 2 secant theta plus 1 equals 0. 2 secant theta equals, equals negative 1. Just trying to get this finished. Negative 1. So secant theta equals negative 1/2. However, I need to take the reciprocal of this because I don't know anything about secant, but I know a lot about cosine. So the cosine of theta is equal to negative 2. And since the domain of cosine is between negative 1 and 1, this one is no good. So I have the secant of theta is equal, minus 2 is equal to 0. I have secant theta equals 2. I take the reciprocal of both sides. I get cosine of theta is equal to 1/2. And that's when theta is equal to pi over 3 and 5 pi over 3. We just want to make sure that these answers are appropriate because both of these functions have values, secant and tangent both have values that are undefined. So I just want to make sure that they're appropriate. Pi thirds is fine with tangent as well as secant. I believe tangent is undefined at pi over 2 and 3 pi over 2 as well as secant, because that's when secant is undefined when cosine is 0, which is pi over 2 and 3 pi over 2. And tangent is undefined at pi over 2 and 3 pi over 2. I just happen to know that. So both of these angles are fine. I didn't square both sides, so therefore I didn't make any extraneous solutions. So those are our final answers.